Hi, this is Ben with Novelux Stereophonic, and today we're going to be taking a look at the Sansui 9090DB stereo receiver. This unit is considered by many to be one of the best receivers from the 1970s, and if you're a Sansui collector, the 9090DB should definitely be on your radar. In this video, I'm going to review some general information about the 9090DB and compare it to some of the other models in the same series. We'll do a review of all the front panel controls and functions, a detailed look at the Dolby noise reduction circuit. Then we will spin it around, take a look at the back, pull off the top cover, take a look at the internal layout and a review of the restoration that was done to the unit, and then we will wrap up with a quick power test of the workbench. So if that sounds interesting, stick around and we'll get started. Let's start out with some general information about the 9090DB. So these were produced from roughly 1976 to 1979. Some key specs include the power output of 125 watts per channel into an 8 ohm load, a frequency response of 10 Hz to 30 kHz, so a nice wide frequency response in the audio band. And then it also features a Dolby noise reduction circuit, which works for both FM and making and playing back your own Dolby tapes. Sansui produced a variety of models in this series, and they're a little bit hard to differentiate, so I wanted to review some similarities and differences and how you can kind of figure out what unit you're looking at. So of course the first thing up here is finding the model number in the glass, but sometimes that is a little bit difficult on a front-facing picture. So to tell an 80 dB and a 9090 dB apart, you can look at the controls. So the 8080 dB is the model down. It has a different output transistor complement and it only produces 85 watts per channel. For cost cuttings, they took away these controls, so your tone circuit is always in on the 8080 dB and it only has one headphone jack. So that's the quick front panel identification for an 8080 dB versus 9090 dB. If you don't see a noise reduction circuit, it's probably an 8080 or a 9090, and there's a common misconception that if you're buying a 9090, it's the same exact thing except no Dolby noise reduction. And that couldn't be further from the truth. The 8080 and the 9090 differ substantially from the DB series. The non-DB units use a quasi-complementary output section, which is comprised of all NPN transistors, where the DB series uses complementary pairs, PNP and NPN. So there's a difference in the actual topology of the output circuit and how much power they can produce. The non-DBs also have smaller power supplies. Their speakers, when you do the AB and the AC together, are selected in parallel rather than in series on the DB. And when you're rotating your input selector on the DB, the dial lights are always on. On the non-DB units, it will turn off the dial when you're not on FM or AM. So if I go to aux, for example, you would lose all of the dial there. And a lot of people will bypass that, and I'm sure Sansui figured that out and made it on all the time on the DBs. There are also some blackface variants that kind of are a shorter model number, but it's pretty easy to identify. So the 890DB and the 990DB are the blackface Euro version of those two units. So that's just a quick overview on how to kind of tell these apart and where they differ. Next, we will take a look at all the front panel controls. Let's take a look at the front panel of the 9090DB and get an idea of how to interact with the unit. So we're going to start off with it powered off to get a an idea from a clean slate here. So on the protect circuit, this light is going to blink at us red until the protection kicks in, and then it'll flip to green. So let's go ahead and do that. Relay clicks, and this turns green. First up, we'll go over the speaker selector. In the off position here, when you adjust volume, your speakers are going to be muted and you're going to be able to adjust the volume of just the headphones. When we go into ABC, the volume control will control all the speakers simultaneously as well as the headphone jacks. Keep that in mind. We also have the option to do A+B and A+C speaker connections. And on this specific model, when you do engage that, it's putting the speakers in series instead of parallel. So if we just have a single set of speakers plugged in and you go to one of these selections, don't think that something's broken when you don't hear anything. It just works a little bit differently than other receivers. It's more common that these would go in parallel. So if you had two 8 ohm speakers, you would present a 4 ohm load to the amp. In the case of the 9090DB, when you put A+C, for example, on two 8 ohm speakers, you would presenting 16 ohms to the amplifier. So we're going to leave it on A and just do a quick test of the audio on the auxiliary here. It's going to be just a second to get track going. So we have volume control here, and then the concentric rear knob is our balance control. So that's far left, center detent, and far right. Now I'm on a mono lapel mic, so we're not going to be able to hear this super clearly, but I just want to demonstrate kind of the general idea of what these controls do. The high and the low filters are basically just a fixed filter that's giving you a roll-off on each end of the frequency response. So as I click these in, that would cut some of the low frequency information and some of the highs. That one's a little easier to hear. We also have tone control here. With these in the defeat position, we can spin the treble and bass controls like crazy and we don't get any response. They're not in circuit. The mid-range, however, we can turn that control because there's no defeat for it. The mid-range is always in circuit on the 9090DB. On the roll-off here, we have a choice between 1.5 kilohertz and 3 kilohertz on the high end, and between 300 hertz and 150 hertz on the low end. So this is just picking at which point in the frequency response do you start that roll-off, right? So I'm going to set these at 1.5 and 300 hertz, so it's the most audible. Start with treble. Actually, bass. Yeah. Treble. Wait for some cymbals to kick in. Meanwhile, loudness. This kind of just bumps up the levels to create a different response curve that's easier to listen to at low levels. All right, treble. Do bass. Go back to defeat. So we also have a mono stereo switch here. So when we engage this, it takes the information from left and right channel, combines it together, sends that to left and right speaker with the same content. What else? That's about it for the basic function. So let's go into FM. Alright, so we've locked into stereo here. If I engage the mono button, it'll kill our stereo indicator as a reminder that you're listening in mono. What FM muting does is when we have this engaged, if we're between stations, we're going to hear static. But if we leave that control out, it's like a convenience feature. If there's no signal, it mutes it so that you don't hear that static between stations. And then it kicks it out once you get locked. So that's that. And then the tape monitors, when I select these buttons, it's allowing us to monitor whatever's plugged into the tape 1 and 2 inputs by passing whatever we've selected here on the control. This calibration control here is part of the noise reduction circuit, so we'll cover that a little bit later. Mic level, when we plug something in here, it just gets mixed into the overall signal, so normally this is not used and you want to have that turned down to 0. Let's do a quick look at AM. There should be something down here. There we go. So we just have signal strength. The tuning meter doesn't come into play on AM. If we go back to FM, we get both. So let's go back up to here to 103.9. So we've got our signal strength there, and then we just center out our tuning meter. I got a turntable plugged into phono 1. We have 2 phono inputs here. This is a single phono stage, so we just have moving magnet, but you can plug in 2 turntables and select between them here. So that's about it for the front panel review. Next up, we will review how this Dolby circuit works, and I'll do a demonstration of creating a Dolby-ized tape. The dB at the end of the 9090DB model number indicates that this model uses a Dolby noise reduction circuit. That consists of 3 controls in this section here: play cal, record cal, and the 5-position selector. The noise reduction circuit has two primary functions, the first being noise reduction on FM broadcast, and the second allowing an end user to create and play back tapes with Dolby noise reduction. So back in the day, there was an idea that if radio stations broadcast in Dolby FM with a specific pre-emphasis, they could reduce the noise floor, and then when it got decoded at the other end with a reciprocal de-emphasis, that the end user would benefit from, a restored flat frequency response, but with much less noise. It never really caught on, so any of these things that have a Dolby FM circuit, it's basically useless. It's almost like applying, say, you push the high filter button when you're listening to FM. It would allow you a fixed alternate EQ curve almost, but in essence, you're just harming the integrity of the original recording because the broadcast does not have the proper pre-emphasis. So the Dolby FM function is basically useless on these. The second function is much more relevant, which is applying Dolby noise reduction to a tape, and then kind of like the Dolby FM, reversing that reduction or that pre-emphasis when you play it back. So I'm going to demonstrate the owner's manual procedure for calibrating the 9090DB with a tape deck of your choice, and then we'll do a test recording. In order to get the best performance of the Dolby noise reduction circuit, some adjustments need to be made on the faceplate of the 9090DB, as well as on the tape deck that you're planning to use with the unit. In order to do that, we have to take this control to the record 1 position. Now what this does is it applies the Dolby pre-emphasis to whatever is going out of the tape 1 output jacks or record jacks. When we push this button here, the unit is going to generate a test tone that is supposed to be at 270 millivolts. Now on my specific unit, even though there's only one oscillator in here and it's supposed to go out to both channels equally, you can see that the left meter is shy of that adjustment. This one is exactly 270 millivolts, but this jack reads around 240 millivolts. Now in the service manual, at this step, they have you adjust these needles to be right between the Dolby Ds. Centered basically between those two red letters on the center of the meter. Now that's all well and good if your oscillator and that circuit is outputting 270 millivolts to both channels, but in my case it's not, so I had to calibrate it a different way, which we'll go over in a little bit. But the gist of this is once you initiate this button, you are generating a tone. So this is what is actually going out to the tape deck. That's going to allow us to set a reference level at the tape deck, which we'll do next. With the test tone being fed from the 9090DB, I now need to make an adjustment of these 2 meters. So first I have to monitor my source input, and we can see that these are not balanced. So I have to raise my input until I get to the 0 dB mark on the tape deck. And again, what I'm doing is feeding both of these channels only from my right input, which is properly calibrated. So now that this is done, we will record this signal. The manual says do it for 5 minutes, but it's just, as long as you can get a nice steady signal for playback. So I'm going to go ahead and start a recording here. So we are recording this sine wave right now. So once this is done, I'll rearrange some connections and I'll be right back. So the only thing I adjusted on the cabling was taking the Y cable that I had plugged in over here on this reference level, and I just swapped it out for a regular left-right RCA for our music test that'll be coming up. So the next step is calibrating this play control here so that we have the proper Dolby reference level. Now remember, this channel was off, so I've recorded this onto both the left and right channel, and then when I did my final adjustment internal calibration on this of those trimmer pots, I adjusted it for a test recording rather than with the oscillator as the service manual suggests. So the next step here is we switch to play for the Dolby NR control. This applies the de-emphasis to the signal, and then I'm just going to turn this off for a second so that we can hear this, and we're going to start the playback. So this is the test tone that we've recorded onto the tape. And then if I activate the meters, we need to get the deflection of these needles into the red Dolby range here. So we adjust the play cal control until we are in between the Dolby Ds. So now we're properly set here for proper de-emphasis, and that's it for that setting. So we're going to stop recording, and now we're ready to record a sample recording. Make sure our counter is at 0 here, so we've got a reference point. We're going to be recording something from the turntable, so I'm going to set my source to phono, and then get the turntable going. Now, when we are monitoring the signal like normal through the source selector, when you flip to the record mode here, the only difference is in volume level. So to set the proper level for my recording, I want to balance these out so they sound about the same. So that's pretty good there. And now this needs to stay in the record position, otherwise it would just be recording without pre-emphasis. We're going to select our tape monitor so that we can... Oh, actually, if we do this, we're going to be hearing the Dolbyized portion, which is going to sound kind of not good, so we'll leave that there. Let's go ahead and start the recording. So we can monitor it in real time here. If we did go to the tape monitor, we're now listening to it with pre-emphasis. So we're going to back off that effect on the playback. So I'm going to let this record out for a little bit, and then we'll come back and play it back with de-emphasis. Okay, to play back our music recording, we need to set the noise reduction control to play. That will allow the de-emphasis to work. We're going to go to tape monitor. I hope that demonstration helps clear up some of the function of the Dolby noise reduction circuit for the 9090DB. Now, if you're interested in purchasing one of the receivers from this series and you're having trouble deciding which one to get, I wouldn't necessarily take the noise reduction feature itself into consideration, but just know that the ones that have it also have the complementary output section with higher output power, and then know that there may be some additional service challenges with this dual-sided PCB, which we'll go over in a little bit. So next up, we will spin this thing around and take a look at the back panel. The back panel of the 9090DB is pretty straightforward. We've got all the input connections here on the left and the speaker outputs on the right. We've got an AM loop stick antenna and all the other antenna connections available here. 2 tape loops with the option for a DIN connection here for tape 2. We've got 2 phono inputs, which are selectable on the front, common ground point there, an auxiliary input, and then 2 sets of pre-outs, with the second pre-out jumping to the main in. So this is what connects the preamp section of the chassis to the power output section. This first pre-out could be used to go out to an auxiliary amplifier or maybe to a subwoofer. It would probably be like a modern way to use that, so that your sub level comes up and down with the volume control on the front of the unit. Over here we have a switched outlet and an unswitched outlet, so this one would come on with the front panel switch. This one is always on. Fuse here, and it has a different indication for whatever voltage you're using, so the 10 amp fuse for 100 and 120, and then a 7 amp fuse for 220, 240. You can select the voltage that this unit operates at here depending on where you are in the world, and then we have 3 sets of speaker outputs. And remember, on this specific model, if you're wiring 2 speakers, they do get ran in series instead of parallel. This is the heatsink that holds the output transistors, so there's a total of 8 output transistors, 2 NPN and 2 PNP per channel. That's it for the back panel. With the top cover off, we can get a much clearer look at the inside of the 9090DB. Before I go into the details of the restoration that was done in this unit, I wanted to give a little bit of reference to the layout so it's a little bit easier to understand the sections that I'm talking about. So this whole section here in the front of the unit is the AM/FM tuner circuit. It has an independent power supply over here. This is the main tuner board, the front end with the tuning gang. We've got some meters here, signal strength and tuning, and a bank of indicator lamps which have been converted to LED in this one. This entire section can be removed and lifted out of the chassis, giving clear access to the switches and controls beneath, and allows us to remove that Dolby noise reduction card for service. This square board on the bottom of here is the power supply. The vertical board that is mounted inside of this piece of metal is the driver card, which feeds the final output stage here that's connected to a heatsink on the back. And then the card down there is the phono stage and source selection. There are more cards underneath this, which we will see shortly. And next I'm going to go over what I replaced, why I replaced it, and some preventative maintenance that was done on this unit. First off, many of the very large high power receivers from the 70s tend to have power supply issues. It's simply because of the designs. The power supplies tended to overheat and cause premature failure of the components. This 9090DB is one of the exceptions to that. The power supply in this specific unit held up very well. These main filter capacitors, I only replaced these because I had put together a parts list for this unit in advance, and I had those on the order, so I had new parts, I wanted to put those in. These are all the kind of larger diameter, larger size capacitors. Every one of these capacitors could have stayed in this unit technically. These were all testing good for their value and their ESR. I had one single capacitor in here that was larger. This capacitor had failed. I believe it failed open. And that was the only one out of the larger ones that had, a failure that it had to be replaced. These don't suffer a lot from heat, but what they do suffer from is a design flaw, which is fusible resistors. This is the Achilles heel of this specific receiver and anything that uses this driver card. If you're looking at one of these units and the driver card hasn't been rebuilt or the seller hasn't claimed to have replaced the fusible resistors, you're going to need to have that done soon. What they do is they're designed, instead of starting on fire or smoking when they are passing too much current, they kind of open up and change in value. And what happens a lot of times, they get momentarily stressed, or from heat they start to drift. They're just notorious for losing their value, and what that does is it drags other parts of the circuit out and eventually causes the protection light to stop working. So it'll just continuously blink red and won't come out of protection. So that's the number one thing that needs to be done on these 9090DBs, is replacement of the fusible resistors in the driver card. And there are some around the protection circuit as well. It's just a general rule of thumb. When you see a fusible resistor in a Sansui, replace it. What's next? So these capacitors, all these little guys, are the ones that were kind of on the edge. In this whole collection of small capacitors that tested a little bit high on ESR, only 3 of them were actually bad. So I was surprised that this unit held up so well over the years for capacitors. And this wasn't one that was babied. This device was heavily used. Sometimes we come across receivers that are, you can tell that they weren't used very much because it has all original lamps, none of them burnt out, things like that. This thing definitely showed signs of steady daily use. Another big thing to address in these units is the RF power supply. Let's see if I can find the resistors for this one. So the original resistors for this are these 5-watt resistors here that are in parallel on this board. They get so hot that they end up desoldering themselves from the board, and it makes this circuit unable to regulate the voltage for the FM circuit. So the recommended replacement is to do a high wattage resistor and offload the resistor itself to this part of the chassis, because this entire section will then act as a heat sink for this resistor and get all the heat off of this board. So along with that, I ended up replacing the semiconductors on that board because they were thermally stressed. And one of the capacitors that faces up vertically with a little like silicone protective sleeve on it that I flip over and put underneath the board instead, so that it doesn't have proximity to this heatsink. So those are the two main things in this unit that should absolutely be done. Is this driver card should be addressed, and the RF power supply should be looked at. In this one, I also did some preventative maintenance. So that was a replacement of the speaker relay, which sometimes these can be cleaned and salvaged, but again, I had the replacement part of my parts list, so I went ahead and put in the new relay. And these are some known noisy transistors that are in the tone circuit, I believe, and those were pulled and replaced with modern equivalents. Some of the additional stuff I did on the driver board, the fusible resistors are the main thing, but while it was out, I recapped it, and I had a issue that was very hard to trace, and I went through replacing one semiconductor at a time trying to find it. These semiconductors were all basically okay and could have stayed in, but again, I had the parts on hand, and I went ahead and replaced those as part of my troubleshooting procedure, and in the end it ended up being a cold solder joint in this board. So a lot of times those little small signal transistors and Zehners and stuff can stay in place, but if you're going for a full rebuild, that card is very easy to work on, so it's not a big deal to get those swapped out. I also did change all of the trimmers, and I did precision 10-turn pots on the DC offset to make that easier to center out. I also encountered on this one a dead chip for the FM circuit. This caused the stereo indicator light to not work, and the station just couldn't play in stereo. Lamps are always something that is going to need to get done on an old receiver. Usually at least one is burnt out. In this case, I opted to go LED on this one, and I did need to do a little bit of tweaking to get specifically the dial pointer to work the way I wanted. While I've got the unit open here, I wanted to do a quick example of what can happen with these LED kits from time to time. So the LED that I was provided to do the dial pointer, in my opinion, is a little bit too bright. And what happens is as I pass the other sources, it kind of reflects off the back of the dial plate and lights up that source, which I don't really like. So what I did is I added a little bit more resistance to the circuit, so I'm going to pull a shorting plug right now. And I've kind of just tamed down that dial pointer a little bit. And now it seems to sit in with the dial a little bit better. It still kind of lights up these sources, but it's much more subdued. So let me do another example. I'll put the original back in and then tame down. Another quick note on LED conversions on the 9090DB. The lamp circuits are AC, so for the power meters and the dial indicator specifically, those ones, it's just like a single LED on an AC supply, so you will get flicker. It's very hard to pick up with the human eye, but it is visible on camera at 24 frames per second. So that basically covers it for the restoration. Every single electrolytic capacitor was replaced. Again, that is a little bit overkill on this specific model. If you want to own one of these forever and you're keeping it for yourself, by all means go ahead and do it. But if you are just having one of these, you're trying it out and you want to have it serviced, the points again that you want to focus on are the driver card and the RF power supply. All right, so next up I'm going to pull this section off and we'll take a look at what's underneath this, which I forgot about. The other thing this thing absolutely needs to have done is a rebuild of the Dolby noise reduction circuit. So we'll go into that next. With the tuner section removed here, we can get a clear look at the stuff that was hidden underneath. This is the protection circuit, tone circuit down here, main filter capacitors. And look at how small those are compared to some of the other receivers. There's just two of these down here. But again, this power supply is plenty for the output section in this unit, and it doesn't overheat. So maybe they're a little bit smaller than some of the other receivers from the time period, but the design seems to have held up better over the years. This is a bank of switches here that's connected via ribbon cables to the Dolby noise reduction board. Now, the 9090DB, every signal runs through that Dolby board, whether you're using Dolby noise reduction or not, and that is one of the reasons that this unit is a little bit tricky to work on. That card is the most intimidating part of the restoration for multiple reasons. First off, it has a ton of parts. The majority of these small capacitors that tested high ESR ended up coming out of that Dolby board. In addition to all those parts that need to be replaced, extracting it from the chassis is difficult. You have to remove every single one of these ribbon cables, and you have to desolder a 4-gang switch that has many conductors, many contacts on it. So without a really nice desoldering station, it's going to be difficult to do, and to do cleanly and get it done in one shot. So that's a word of warning. If you're working on one of these and you don't have a lot of experience desoldering, tackling that Dolby noise reduction card is going to be a big challenge. If you have the proper tools, it just takes a lot of patience. So on that card, the other big thing is it's a very early dual-sided PCB. All the other PCBs in this unit are single-sided, very easy to service. But that double-sided card, what happened is their design of the vias, they hadn't quite mastered the plated through hole, and they had solder just inside of them connecting one side of the board to the other. And because of corrosion or defects in the board, eventually some of those vias fail, the paths that connect the top to the bottom of the board. So the routine maintenance that has to be done on that is putting a pin, a small wire through every single via and resoldering it. And a lot of them are underneath that 4-gang switch, so you have to remove in order to do the job properly. So again, that is the most challenging part of this restoration. All right, the 9090DB is now set up at the bench, and we're going to do a power test. So the rig is the A output of the 9090DB fed into my 8-watt dummy load. Across that load, I have a 10x attenuation going into either channel of the oscilloscope, and then a direct connection across the left channel going up to my distortion analyzer. Now, my signal gen is a Siglin over here, and this one's spec'd at about 0.08% THD. So I'm not feeding a pure sine wave into this device, so our distortion measurement is not going to be super accurate, but it will give us a reference at clipping. So I'm feeding a 1 kilohertz sine wave into the 9090DB at about 1 volt peak to peak into the aux, so I'm just raising the volume control to drive this into clipping. I'm going to overlay these two channels so that we can look at the channel balance. It's pretty good. So we're looking for when this waveform, you see how it's distorting at the top and the bottom? And I'm at over 1% THD. If I take that back down below clipping, it settles off at about 0.3, but again, this measurement is skewed. So I'm going to take it into clipping again. So that's just into clipping, so we see that distortion at the top and the bottom of the waveform. And if I flip this into volts mode here, right about 35 volts RMS. And if I come down and look at the measurement feature inside of my scope, I have 35.7 on one channel and 35.16 on the other. So roughly 35 volts RMS across the 8 ohm load. So we just need to use Ohm's law to calculate the power. 35 times 35, divide that by 8, and this amp is currently outputting over 150 watts per channel. So it's only spec'd at 125, but a lot of times they conservatively rated these things, and it has to adhere to a certain THD spec. So once I get a lower distortion signal generator, I'll be able to really compare these things to the spec sheet. But that's why sometimes you hear people say this amplifier is very conservatively rated, because on a bench test, when you take it up into clipping, it will actually test higher than what's on the spec sheet. Again, this is Ben with Novolux Stereophonic. Thank you so much for coming to my channel and checking out this video on the Sansui 9090DB. If you enjoyed this content and want to see more, please feel free to subscribe, and there'll be many more restorations to come. Thanks again.